Hello everyone, here we are again, Pre-Calc Lesson 85, Advanced Trig Equations and Clock Problems. Okay, Advanced Trig Equations. Okay, if an equation contains two trig functions, then use trig identities. Okay, it just sounds simple like that, but let's get into a couple examples. Okay, we're going to solve it when theta is in between 0 and 360, our normal theta. And our first one is we will have 3 tangent squared of x equals 7 secant of x minus 5. Okay, we have two trig functions. This is 1 and this is 2. And so we need to use a trig identity to get it down to the same trig function. If we look here, we have the trig identity that the tangent squared of x equals the secant squared of x minus 1. Right? And we've seen it before as the tangent squared of x plus 1 equals secant squared of x. Doesn't matter, right? We just move the 1 over, so we have tangent squared of x, which we're going to plug in here. So we will have 3 times the secant squared of x minus 1 equals 7 secant of x minus 5. If you're having troubles with your trig functions or your trig identities, we need to get that under wraps now because we're starting to do problems that apply them. Now let's distribute the 3. So we have 3 secant squared of x minus 3 equals 7 secant of x minus 5. I want to get all of my terms over to one side. So 3 secant squared of x minus 7 secant of x plus 2 equals 0. Okay. Now at this point, okay, I can factor or complete the square or use the trig function. Okay. I'm going to first set x equal to the secant squared of x to make it easier to see. So I have 3x squared minus 7x plus 2 equals 0. Okay. And if you want at this point, okay, we can actually factor this. I'm going to show you what I'm going to factor it to. I'm going to factor it into 3x minus 1 times x minus 2. Now, how I did that, these first terms here have to multiply to give me 3x squared. They do. Then I do 3x times negative 2 plus, in this case, minus x, right? This gives me minus 6x minus x, has to give me my middle term minus 7x, and then these last terms have to multiply to give me positive 2. Okay? If you don't want to factor it that way and you want to use completing the square or quadratic formula, that's totally fine. Now, I'm going to set my mini equations. So 3x minus 1 equals 0 and x minus 2 equals 0. So I get x is 1/3 and 2. Now I know that x is secant squared of theta. So I now get the secant squared of theta is 1/3 and the secant squared of theta is 2. Okay. Now what I'm going to do is I'm going to rewrite this. It's secant, which we know is cosine. So I'm going to say 1 over the cosine squared of x equals 1/3 and 1 over the cosine squared of x equals 2. Then I'm going to flip my fractions. Cosine squared of x equals 3 or the cosine squared of x equals 1/2. Now, okay, here we know that our cosine squared of x is not going to equal 3. Okay, that's one of our extraneous solutions. Okay, we discard it, but on this side we know that cosine squared of x can equal 1/2, so we take the square root. So we have the cosine of x equals plus or minus 1 over root 2. Now here comes into play my 45, 45, 90 triangle where I have 1, 1, root 2. Oh, silly Miss Smith. X should equal secant theta not secant squared theta. I'm going to write that on a separate piece of paper. Just pretend we're here. Okay, so we had 3x squared minus 7x plus 2. Sorry for that, guys. And we factored it into 3x minus 1 times x minus 2. So we get x is a third and 2. And then we say secant, right? X is the secant of x. So secant of x is 1/3, or secant of x is 2. We discard the 1/3, and it tells me the cosine of x is 1/2. Not cosine squared, sorry. And we know that cosine is 1/2, right? That's from our 30, 60, 90 triangle. We know that when x is 60, right, the cosine of 60 is 1/2. And we also know that cosine of 300 is 1/2 because x is positive in the first and fourth quadrants. All right, let's do another example. Example 2, we have 2 sine squared x equals 3 plus 3 cosine of x. Again, we have two trig functions, so I'm going to use a trig identity. And I'm going to use the trig identity that says the cosine squared of x plus the sine squared of x is 1. So the sine squared of x is 1 minus the cosine squared of x. So I have 2 times 1 minus the cosine squared of x equals 3 plus 3 cosine of x. Distribute my 2. So I get 2 minus 2 cosine squared of x equals 3 plus 3 cosine of x. I'm going to get everything on the same side. I'm actually going to move it over to this right side over here. So I will get 2 cosine squared of x plus 3 cosine of x plus 1 equals 0. Okay? And I can factor this. I'm going to let x equal to the cosine of x. So I have 2x squared plus 3x plus 1 equals 0. I need two things that multiply to give me 1, which is just 1 and 1. So I know that these terms here will be 1. Two things that multiply to give me 2x. Well, that's 2x and x, right? And then I know I'm going to have a plus here and here because this is a positive 1. So 2x times x gives me 2x squared, and then 2x times 1 is 2x plus x gives me 3x. 1 times 1 is 1. So I get 2x plus 1 equals 0, x plus 1 equals 0. So x is negative 1/2, or x is negative 1. Now we know that x is the cosine of x. So we say the cosine of x is negative 1/2, or the cosine of x is negative 1. And we can have both of those situations, right? The cosine of x is negative 1/2 at 120 and 240, and the cosine of x is negative 1 at 180. Again, you should be much more familiar with all of your trig functions, especially your trig identities. Okay, so you can kind of flip back and forth through everything. Let's do another problem. We have 2 tangent squared of x equals the secant of x minus 1. Again, you have two trig functions, so you need to get it down to 1 by using a trig identity. And I'm going to use the trig identity that we used before, saying the tangent squared of x is the secant squared of x minus 1. So I will have 2 times the secant squared of x minus 1 equals the secant of x minus 1. Distribute my 2. So 2 secant squared of x minus 2 equals secant of x minus 1. Get everything on one side. So 2 secant squared of x minus secant x minus 1 equals 0. Okay, now we want to see if it's possible to factor this. And it is. Okay, I need two things to multiply. First, let's set x equal to secant of x. Two things to multiply to give me negative 1, which is positive 1 and negative 1. Two things to multiply to give me 2 secant squared x. Okay, so I'm going to have a 2x here, 1x there. When you get to this point of factoring, always make sure you check your work, right? 2x times x is 2x squared. Right, so 2x squared minus x minus 1 equals 0. We plug in x for secant x. 1 times negative 1 is negative 1. And then we have negative 2x plus x gives me negative x. Okay, so 2x plus 1 equals 0, x minus 1 equals 0. I get x is negative 1/2 and x is 1. Now this tells me the secant of x is negative 1/2, or the secant of x is 1. So the cosine of x is negative 2, or the cosine of x is 1. Well, we know that we can eliminate that as an extraneous solution. Cosine of x is not going to be negative 2. But we know that when x is 0, cosine of 0 is 1. Now, the reason we don't put in 360 is because we have parameters that I didn't write. 0 is less than or equal to theta is less than 360. It's less than x. Strictly less than 360. It's not less than or equal to, so we don't include 360. All right, let's go to our next type of problem. These are a little harder. Clock problems. Literally, we're talking about a clock. Okay, the equation that we have is rate times time equals spaces. Okay, spaces, they are 61-minute divisions, which makes sense because on a clock there are 60 minutes. Okay, the rate of the minute hand, is 1 space per minute, and the rate of the hour hand is 5 spaces per 60 minutes, or 1/12 spaces per minute. Okay? Now, what does this all mean? I'm going to explain it through an example. I think we're on example 4. The hands of a clock point in the same direction. In how many minutes will they point in opposite directions? Okay, so let's first imagine we have a clock, right? And it's telling me that my minute hand and my hour hand are pointed in the same direction, like at the 12 o'clock, for example. Now it's telling us we want to know, right, when they will be pointing in opposite directions. So that could be like this, right? It could be up and down. It could be anything like that, okay? Now, what we need to do is we need to set up a couple different equations. So we will have the rate of the little hand, right, our hour hand, times time. If you want to label this as hours, that's fine. And times time with a little, that equals spaces, right? Rate times time equals spaces. The rate times our big hand times our big hand equals space plus 30, right? Our big hand is going to move 30 spaces to where it's facing down, okay? Or 30 spaces to where it's exactly apart, right? Our little hand is just moving 1 space at a time, and our big hand is moving, it's going to be 30 spaces apart, okay? The rate of my big hand, my minute hand, is 1, right? 1 space per minute. The rate of my little hand is 1/12. And the time is going to be equal. Okay, because they're both moving for the same amount of time. All right, now I have these equations. I need to start to substitute things in. Now I know that the rate of my little hand is 1 over 12, so I can put that in here. So I'll have 1 over 12 times the time of my little hand equals s. And I'm going to put in 1 for the rate of my big hand, so I'll have the time of my big hand equals s plus 30. Okay. Now if this is s, right, I can plug that in here. So I'll have t of my big hand equals t of my little hand over 12 plus 30. And I know that my time of my little hand and my time of big hand are equal, so I just get t is t over 12 plus 30. Okay, and I'm just going to solve this. Okay, I'm going to multiply everything by 12, giving me 12t equals t plus 360, so 11t equals 360. So t is, grab my calculator. Your book leaves mixed numbers. Don't ever, ever, ever leave mixed numbers. We can't simplify it. It's just 360 over 11. And the time is in minutes. We are concerned with all of our time in this is in minutes. We have space per minute, 5 spaces per 60 minutes. We're not doing hours, we're doing minutes. Okay, so if we look back here, the hands of a clock point in the same direction. How many minutes will they point in the opposite direction? Okay. If my little hand, meaning my hour hand, is moving by spaces, then my big hand, my minute hand, is moving by 30 more spaces per minute, essentially is what this is saying. Okay. Let's do another problem. Get it to make more sense. It's 3 o'clock. In how many minutes will the 2 hands of the clock point in the same direction? Okay. This time I'm going to use hour hand and minute hand. I think that will be easier. Okay, so I will have the rate of my hour hand times the time of my hour hand equals space. The rate of my the rate of my minute hand times the time of my minute hand is going to be this times space plus 15. Okay, before, when they were pointing in opposite directions, we added 30. When they're pointing in the same direction, we only add 15. Now, the rate of my hour hand is always 1 over 12, and the rate of my minute hand is 1. Again, the time is equal. Okay, so now we're going to plug things in. So I'm going to plug in the rate here. So I have 1 over 12 times my time of my hour hand equals s, and the times of my minute hand equals s plus 15. I know that the times are equal, so this is t over 12 equals s, and t is s plus 15. Okay, I'm going to plug this in for s. So I get t equals t over 12 plus 15. Multiply everything by 12. So I get 12t equals t plus 180. So 11t equals 180. And t is just 180 over 11 minutes. Okay? All right. That's all for today's lesson. If you have any more questions, write them down, bring them tomorrow. We'll go over a few more problems like this tomorrow in class.